Ravi, Jagannathan. I work at Juniper. I do virtualization and secure cloud computing. So here I'm going to talk about the various choices of overlay. There in OpenStack there are we have choices, and how we go about picking one is very important. And I'm just going to talk about some of the issues and compare a couple of entities under Neutron, which one to pick. Overlays are very important for data centers as well as service providers. This could really impact your cloud deployment if it's chosen wrongly. So one needs to pay attention to the overlay implications of choosing an overlay. So what is an overlay? I just wanted to clarify one terminology because so we are all on the same page. The payload itself that is being carried in the traffic, that's called the overlay, and the encapsulation that carries the payload is called the underlay, just to make sure we are all on the same page. Overlay, as you guys all know, helps one to create a much larger number of virtual subnets over the existing physical network. It adds functionality to the existing network without altering it. There is more of a one can create logical tenant topologies over the same physical network. It also decouples the logical topology from the physical underlying network topology. So overlays are useful. However, the choice of the overlay is based on application in hand, and it also depends upon how the corresponding Neutron plugin help to implement various overlays. So how the Neutron plugins implement those things have bigger implications, and I'm going to compare and contrast that and illustrate the point with picking an example between comparing two network plugins. So if you guys look at the network plugins, some of them are deprecated. Open vSwitch going forward is on the path of deprecation, and so is the Linux bridge. So we are going to compare the ones that are there going forward, and it turns out one is the ML2 modular layer, and next one is OpenContrail. So those two seem to be the top two Neutron plugins in the market today. If you take out the ones that are being deprecated. So you can see it shows which one are in production, which one is under development and QA, which one is at the proof of concept level. So if you take a look at all of those things, I think it makes sense at this moment in time in the OpenStack's evolution. It's meaningful to compare ML2 and OpenContrail. So there are several overlay options that people have. One is VXLAN, which is very popular nowadays, and it can stretch the data center, but it doesn't necessarily carry the tenant topology information. It's an overlay. It will carry the traffic using VNI identifier, and it mostly carries L2 traffic, L2 overlay, and it carries on UDP, thereby providing better entropy because UDP naturally inherently comes with that. Another interesting thing is NVGRE, and it carries L3 payload. That's an interesting aspect of it. So it also, but it doesn't span the data center across the data center. It's one of the things about NVGRE. Another one for historic purposes, what considering is VLAN. It can still be useful in places, but it comes with a lot of baggages, not scalable, can't do multipathing. Need to configure the intermediate devices with the corresponding VLANs for it to carry the traffic. Doesn't do true tunneling. Anyway, it's there for the historic purposes, right? So we are going to see how ML2 and OpenContrail compares with these various overlay options being in place. Both of them have have their own advantages. If you guys look at the overlay that we just discussed, the overlay in itself doesn't negate the need of a gateway. To get past the physical boundary, oftentimes you need a gateway. Definitely for ML2 you need one. So that is an expense, that is a complexity. So one needs to take such things into account in choosing the network plugins, that is ML2 or OpenContrail. So in that context, we are going to be exploring a bit more about the advantages and disadvantages between ML2 and OpenContrail. So in addition to what overlay is being chosen, how it is implemented also matters a lot. And the implementation, if the implementation carries the tenant topology information, it'll actually simplify the architecture and the implementation, and it can eliminate a gateway, it can span across the data centers, it can provide many different advantages. So this is another factor to consider while building out your data centers and the OpenStack cloud. The decision should be based on tenant topology, workload, IP headers also. So in this context, what we are given this context, we are going to compare ML2 versus OpenContrail. So how they fare better. ML2 has its advantages. It is designed after OVS, so it has eliminated many different things. It comes with many plugins. One can configure various company plugins. It is there. The advantage is there, and it encompasses OVS also. And by and large, it supports L2 payload, and so that's one thing about ML2. However, one other interesting thing about ML2 is it doesn't have the knowledge of the tenant topology details. It's just seems to be somewhat detached from that. It's just the way maybe ML2 will evolve, but as of now, that's the status of ML2. So these ML2 features and limitations, is what people have been working with so far. In the evolution of this, data centers, cloud, and networking, everything, Contrail basically has thought through some of the issues. So they have done a better job of integrating some of the tenant information with the network, and actually the advantages are great, and it proves itself in the marketplace because it is second to ML2, and that's why we are comparing it today. One of the advantages OpenContrail has is it can carry both L2 and L3 the payloads. That's that's interesting because it actually can help in many different ways. Another thing is enforcing security policies. One can actually establish connection between virtual networks. This is an important thing because, like one gentleman was telling me today that he wrote a blog where there's a 3-tier web service or database application. Each one tend to be its own tenant network, and when they need to communicate, he can simply set the security policies. So the packets could flow across the tenant network, which is a great advantage. So which could be simply done with the security policies. And network abstraction across the physical network boundaries, that is something that is definable, that is easily doable because it does L3 also. That's another advantage of OpenContrail. And you also eliminate the needing a router. ML2 need a gateway functionality, but with Contrail vRouter architecture, it has a built-in fully distributed forwarding policy, which actually policy enforcement and services that helps you eliminate that the external router. So because of that, those who are deep into networking will know, because of that you could actually do load balancing very easily. NAT becomes local all of a sudden, right? And then the port mirroring is there too. That's another thing OpenContrail does. It's also, the IP-based tunneling we can do. So VXLAN in UDP, and it can also be tunneling agnostic. That is another advantage of the OpenContrail. So this is an interesting aspect. It includes the topology information of the tenants. So thereby it actually has an advantage. It can span across the data centers even if the topology spans across the data centers. The another thing is, obviously, you can do service chaining easily. I mean, other people can do service chaining too, but the thing is, here you can do a lot more easily. There just by defining policies and using security aspects that it has built in, and it has a seamless extension of tenant networks across the data center boundaries, which comes for free when you use OpenContrail. So these are the advantages. So here is the reason why it's one thing to choose an overlay, but how it is implemented is also very important, and that's where OpenContrail actually is a better tool to use than ML2. So that's basically those are the details. We will take the questions after the talk is over. Thanks. Appreciate that.